tracing assignment. Let's see my scene first. We have two spheres, one black and one green, and four walls, two blue on the left and right, and one red on the top, and a gray one in the bottom, and one mirror at the back side. Next we can see there are three lights diffused as these two balls. On the black ball we can see the reflection of green ball and reflection of right hand side blue wall, reflection of top red wall and left blue wall, and we can see similar kinds of reflection on the green wall as well. Then on the mirror we can see the reflection of these two balls, and in this green ball you can see blue red, like another depth of the reflection. Then we have shadows here crafted by the reflection and the lights, and this makes the a jiggy appearance on the balls. Now let's see the code behind this scene. I have created my code on JavaScript using JavaScript library 3.js and referenced its example for understanding its APIs. My first file is scenemaker.js, where I am setting my camera at G is equal to 500. Next, this library provides a mesh form material for creating materials which will be used for assigning values to the objects, where I am giving color, specular code, shininess, vertex colors and shading. These materials are used for creating objects. We have two types of geometries defined, sphere geometry and plane geometry, and then we are creating objects like a plane for bottom and adding it to our scene. At last I have declared three light objects with their position and intensity and added them also into the scene. Next I have created a recursive RayTracing renderer and I am calling its render function. So to understand this code we have to understand the algorithm first. So in the first idea to have ray tracing was forward ray tracing, where a lot of light rays will be emerged from the light source and they will bounce back from the objects and enter through the camera. The main problem was there were a lot of light rays and only a few can contribute to the image. So the next one was backward ray tracing. Backward ray tracing, where we start our rays from camera and pass it through the view image, and all the pixels were the color of the pixels were designated according to the interaction of the rays with the objects. So similarly we have our camera fixed at a position and we start all the rays from camera. But the view image is very large. So what I have did is I have created a block size of 64 and all the rays that passes through this block size are traced first, and so for every pixel of this block I am creating a ray with origin as the camera position and directed toward the pixel of the block. We have some properties defined for calculating this ray. Next we are calculating if this ray hit any of the object in our scene. So this method will return all the objects that are hit by this ray. If nothing is hit, we will set the background color, and if we found some object that is being hit, we have to calculate the pixel color. So for calculating this pixel color we have to see if this point where this ray has hit is illuminated by the light or not. So we have started another ray with this point as the origin and directed towards all the light sources present in the scene. If these rays are objected or intersected by any other object, that means they will form a shadow. They are not illuminated by the light. And if they are not forming shadow, we will calculate the light contribution of this ray on this pixel and add it to the output color. And now if this is a type of mesh format, we will add light contribution caused due to its intensity and specularity and add that as well in the output color. Now if this object is of type mirror or glass, then we will calculate its reflectivity and we will calculate this as per our requirement according to the max recursion depth. For this assignment we have max recursion depth as 5. So if it's a mirror, it will be a reflection and reflected ray will be calculated. And if it's not a mirror or glass type or any other object type, then a refracted ray will be calculated. For this ray, the point of origin will be the point of intersection, and the direction will be calculated via the normal as per the reflection or refraction. This refracted or reflected ray will also contribute to output color and will be added. Thus, this completes ray tracing on this pixel. Similarly, ray tracing will be performed on every pixel of each block and looped over the whole image. Now let's see our rendering of image. You can see how block by block the whole image is being rendered on the screen. This gives a better feeling of an animated image. And thus I complete my assignment with the output of my code. Thank you.